Today we're going to factor trinomials. What does that mean? You know either of those two words mean? Trinomials is 3 terms, right? Okay, so as obvious by the 2 examples you can already see, that's 3 terms. What's factoring mean? Breaking it down into its parts, remember? Okay. Yesterday we factored special cases. We did sum and difference of squares. We did sum and difference of cubes. We did factoring by grouping. How did you feel about factoring by grouping? When there was 4 terms? Pretty good? Well, I'm glad about that because we got to do it again today. Does that seem weird that we're going to do factoring by grouping when we have 3 terms? Well, we're going to make it have 4. Okay? Now, there's 2 ways you can factor trinomials. One works every time, so I'm going to teach you that one first. And the other way is easier, right? But it doesn't work every time, so I'll teach you that one second. Okay? So here's what first of all you need to know. Okay? The term beside the square term is called A. The term beside the term that is not squared is called B. And the constant is called C. So the first thing I need you to do is I need you to be able to find 2 values. I need you to be able to find AC and I need you to find B. Well, if I'm asking you to find AC, what do you think I'm wanting you to do with A and C? Multiply them, right? So what in this problem is A? 3, and in this problem what is C? -5. So what is 3 times -5? -15. And in this problem, what is B? -2. So what I need you to think of are 2 numbers that multiply to be AC and add to be B. Okay? Well, it's easiest to start thinking of the numbers that multiply to be AC. So in this case, the only 2 numbers that multiply to be AC, to multiply to be -15, are 1 and 15 and 3 and 5. But since it has to be -15, what has to be true about one of these numbers? It has to be a negative, right? One of them has to be negative, one has to be a positive, right? Well, I have to figure out which combination of either this pair or this pair can I multiply together to be a -15, but when I add them, it's -2. So 3 and 5, I agree with, but which one has to be a negative? The 5 has to be a negative so that when I add them together, I get a -2. Does that make sense? Okay, so this is what we came upon. All right, now what we're going to do is we're going to rewrite our problem, 3p squared, but instead of writing -2p, I'm going to write the 2 values that I just decided on. So plus 3p minus 5p minus 5. So what I need you to notice is that I just wrote down the first term and I just wrote down the last term. The middle term I split into 2 parts. Do you see how this is still the same equation as the first one? But the middle term has been split into 2 specific parts. It can't just be any random numbers. It has to be these specific ones. Does that make sense? Now look how many terms we have. 4. We can factor by grouping, can't we? What's common in the first 2 terms? 3p, right? What's left if I factor out a 3p? P plus 1. Very good. What's common in the second 2 terms? Knowing that I have to have a parentheses that says p plus 1. A -5. Remember we did an example like that yesterday, right? Okay. What happens if I divide out a -5? What do I have left? P plus 1, right? If I divide each term by -5, I get a p and a positive 1, right? Now, what's common in these 2 terms? P plus 1. And what's left over if I factor out a p plus 1? 3p minus 5. Any questions? Now, here's what I need you to understand. There's a ton of ways out there for you to factor trinomials. a ton. There's a box thing that you can do. There's a triangle diagonal thing you can do. To me, this makes the most sense. It's the clearest about where numbers come from, okay? And to me, it's the easiest. Not only is it clear, but it's easiest because we talked about factoring by grouping yesterday, and you guys were pretty good at it yesterday. Okay? Look at this next example. So first thing I have to do is decide what? Well, first thing I'm going to do is label A, B, and C. Now, is that required every problem? No, but it is helpful, right? Okay. So AC, what's AC in this problem? Negative 18. And what's B in this problem? 3. So numbers that multiply to be 18. 1 and 18, 2 and 9, 3 and 6, right? So what combination of numbers of these partners that I just wrote down will multiply to be negative 18 and add to be a positive 3? Negative 3 and 6. Is everybody okay with that? Okay. So I'm going to rewrite my problem. 2n squared, but I'm going to use these two instead of that middle term. Minus 3n plus 6n minus 9. Once again, all I did was rewrite the first term and I rewrote the last term, but I split the middle term into two parts. Do you see that? Now I'm going to factor by grouping. Group the first two, group the last two. What's common in the first two terms? N, very good. What's left if I factor out an n? 2n minus 3, excellent. What's common in the last two terms? What are they both divisible by? 3. What's left if I factor out a 3 from each term? What's common in these two terms? What are they both divisible by? 2n minus 3. And what's left if I divide by 2n minus 3? n plus 3. Now, is there a way that I can make sure, like a way to check my answer? Is there a way to check to make sure that this is the right answer?
Probably. I'm not sure.
How did I get from here to here? I factored, right? Remember yesterday we talked about factoring being almost or very similar to what? Dividing. So how could I take this answer and check to see if it was this problem? Multiply, right? So what's 2n times n? 2n squared, okay? What's 2n times 3? 6n. What's negative 3 times n? So I have a 6n and a negative 3n, which gives me 3n, and then I have negative 3 times positive 3. So is this the right answer? Yeah? Let's go ahead and check this one while we're here. P times 3p. 3p squared. P times negative 5. Negative 5p. 1 times 3p. 3p, so I have a negative 5p and a 3p, which is negative 2p, and then I have a 1 times a negative 5. Negative 5. Now, did you also notice that as I was doing my multiplication, p times 3p is 3p squared, p times negative 5 is negative 5p, 1 times 3p is 3p, and 1 times negative 5 is negative 5. It's this line. Does that help a little bit? Okay. Now, one thing I've done a poor job of, I apologize, one thing I've done a poor job of today so far is to say to you, what should we be checking first? Before we find AC and before we find B, what should we check first? It was the first thing I told you to check yesterday. Greatest common factor, right? Greatest common factor. Could I still factor these if there was a greatest common factor in them? Yes, right? I still could, but the numbers would be bigger. And don't we want to try to make it easier on ourselves if at all possible? So when we see a problem like this, 9x squared minus 24x plus 12, our first instinct might be to just go ahead and start A, C, and B. But if I say A, C in this problem, I get, what, 108? Ugh. You want to find all the multiples of 108? Yeah, me neither. But what do you notice about all three terms in this problem? They're all divisible by 3, right? So if I factored out a 3 from the very beginning of the problem, what does that leave for me? Oops. Sorry. 3x squared minus 8x plus 4. Wouldn't you rather figure out AC of 12 and a B of negative 8 instead of an AC of 108 and a B of negative 24? Isn't that going to be a lot easier? So here's A, here's B, and here's C. Now this 3 is still part of the problem, and as I go to my next steps, I've kind of got to drag it along with us, okay? But it doesn't mess with my AC and my B that I'm trying to find. So again, in this problem, my AC is 12, and my B is, very good, negative 8. So 1 and 12, 2 and 6, 3 and 4. What combination of these are going to give me a negative 8? So again, I'm dragging this 3 along, and I've got 3x squared minus 2x minus 6x plus 4. Got it? Now I'm just factoring my grouping. Those two and those two. What's common in the first two terms? X. If I factor out an x, what's left? 3x minus 2, right? Is it okay that I covered this 3 up? I just don't want to get distracted by the 3. Are you okay with that? What's common in these two terms? 2 for sure, but I need a parentheses that says 3x minus 2. So I need to take out a negative 2, don't I? 3x minus 2. What's common in these two terms right here? 3x minus 2. And what's left if I factor out a 3x minus 2? X minus 2, right? Any questions about that? A, B, C. In this problem, what is AC? 18. And what is B? 11. You know how on each of these problems I've made this little chart for you every time? Can we not do that and just do it in our head? Can we write it down if we want to? Absolutely, right? But is there times that you can see or you can think about in your head what two numbers multiply to be 18 and add to be 11? What are they? 2 and 9, right? 2 and 9. So, a squared plus 2a plus 9a plus 18. Brought that one down, brought that one down, split this one into 2 parts. What's common in the first two terms? A. What's left if I divide out an A? A plus 2. What's common in the second two terms? 9. What's left if I divide out a 9? A plus 2. Very good. And what's common in these two terms? Right here? A plus 2. And what's left? A plus 9. Now, this one is a special one. Remember I told you there was an easier way, but it doesn't work every time? We can actually do this one way faster. Really.